Hi guys, this is the series on machine learning demystified. I am Dr. Ganesh. This is the 14th video. In the previous videos, we have explained various steps involved in machine learning, right from data gathering to data visualization. And ever since that, we have been seeing several machine learning algorithms. Uh, we have seen different types of supervised learning, uh, such as classification algorithms, regression algorithms, including naive Bayes classifier, decision trees, etc. So let's look at one of the very popular unsupervised learning algorithm today. Now, what is unsupervised algorithm? As you can see here, if I give a small kid these three different items mixed up and I ask him or her to just cluster them, group them, and we are not telling that kid nothing else, the kid will still be able to group them into three different categories, as you can see here. And that is primarily because the kid can learn by himself different characteristics of three items, and then the kid can start segregating supervised learning. So a very popular example of unsupervised learning which I just mentioned is also called as clustering. Clustering is the task of dividing the population of or data points into a number of groups such that data points in the same groups are more similar to other data points in the same group and dissimilar to data points in other groups. As you can see here, yellow balls are segregated as one cluster, the green pyramids are segregated as one cluster, the red cubes are segregated as one cluster. A historical example way back to 1854. This is on the British famous Broad Street cholera outbreak. A scientist physician John Snow analyzed using the data available, and he got a map which looks like this. He found that locations with the most cholera cases are on certain part of the street and they all had polluted wells, thus exposing the problem and the solution. So guys, machine learning goes back to 1800s. So clustering applications, it can be used in many places including marketing, where we can do customer segmentation, or insurance, used to acknowledge the customers, their policies and identifying frauds, or maybe for city planning to make groups of houses and to study their values based on their geographical locations, etc. etc. What are some of the requirements of clustering? Scalability. So clustering can give clustering on only a sample of a given large dataset may lead to biased results because that sample may not have all the uh, required data. So highly scalable clustering algorithms are needed. And the ability to deal with the different types of attributes. Most of the clustering algorithms are designed to cluster numeric data-based, but applications may require clustering of other data. Could be ordinal data, could be mixer of data, etc. Now, discovery of clusters with arbitrary shape. Quite a few clustering algorithms works on algorithms such as distance measures such as Manhattan distance. We will see it later, don't worry guys. Algorithms using distance measures are generally of spherical shape, but clusters could be of any shape. So it's important that algorithms should be able to be very diverse and ability to deal with noisy data. There could be a lot of noises in the data such as outliers, missing data, erroneous data. So we need clustering algorithms that are robust to noise. What are some of the major types of clustering algorithms? the major types are partitioning methods, hierarchical clustering, fuzzy clustering, density-based clustering, and model-based clustering. Partitioning method, as you can see in the picture, it partitions the data into different spaces. You can see all others example how they works. So in hierarchical clustering, for example, they are making into different hierarchy of data to group them. And for example, density of cluster looks at how dense a particular data is and then group them, things like that. I request you to go through the reference URLs in case you're interested in knowing different types. What are some of the business use cases? As we said before, maybe in business segmentation like purchase history, application segment of by activities on application, define personas based on interest, or group inventories by sale activity, or in case of sensor measurements, maybe separate audio from video, identify groups in health monitoring, or to detect boards and anomalies. There are multiple ways it can help. Now today we are going to look at one of the famous clustering algorithm, which is a partitioning method known as K means clustering. You see here this partitions the persons into based on width and height. No width but very high, quite a huge width like me who has a big tummy, and both width and high are high. So K-means clustering is a type of unsupervised learning which is used when you have unlabeled data. You know that, right? Now the goal of the algorithm is to find groups in the data with the number of groups represented by the variable K. The algorithm works iteratively to assign each data point to one of the K groups based on the features that are provided. Data points are clustered based on feature similarity. The results are the centroid of the K clusters, which can be used to label new data, and labels for the training data. So its inputs are the number of clusters and the dataset. The algorithm starts with the initial estimate for the K centroids, which can either be randomly generated or randomly selected from the dataset. The algorithm then iterates between two steps. So let's see the first step, which is the data assignment step. So each centroid defines one of the clusters. In this step, each data point is assigned to the nearest centroid based on the squared Euclidean distance. So if Ci is a collection of centroids in a set C, then each data point X is assigned to a cluster based on argmin distance Ci, X the whole square, with distance is the standard Euclidean distance. Let the set of data point assignments for each ith cluster centroid be Si. Now, in the second step, which is a centroid update step, centroids are computed. This is done by using the mean of all data points assigned to that centroids cluster. Ci equal to 1 over mod of Si sigma xi, which is an element of Si xi. So the algorithm iterates between steps 1 and 2 until the stopping criteria is met. That is, sum of distance is minimized or some maximum number of iterations are reached. Demonstration, you can see here there are three initial centroids randomly generated, three different colors. Second step, K clusters are created, so three clusters are created based on this observation. And the centroid of each K cluster becomes a new mean based on the data. And the steps are repeated, these two steps are repeated until there is a stopping point. So you see here a small visualization of how it works in different iterations. It's almost converged, right? How do you determine K? So one of the metrics that commonly used to compare results across different values of K is the mean distance between data points and their cluster centroid. Mean distance to the centroid as a function of k is plotted, and the elbow point, where the rate of decrease sharply shifts, can be determined, roughly determine k. You can see here in this example k is 4. Let's take an example. K means clustering intends to partition n objects into k clusters, in which each object belongs to the cluster with the nearest mean. This method produces exactly k different clusters of greatest possible distinction. The number of clusters k leading to the greatest separation is not known a priori and must be computed from the data. The objective of k-means clustering is to minimize total intra-cluster variance, or the squared error, as shown in this particular equation. So x minus c the whole square, sum of number of cases and sum of number of clusters. And this distance function is what I am calculating to minimize. Let's take an example. Clusters the data into k groups and select k points as we said before. Assign object to the closest cluster center according to the Euclidean distance function. Calculate the centroid or mean of all the objects in each cluster. Repeat step 2, 3 and 4 until the same points are assigned to each cluster in consecutive rounds. Let's see. Suppose we want to group the visitors to a website using their age, one-dimensional space as follows. There are 19 entries. So let's take two clusters. And two values are taken randomly, 16 and 22. Based on which we grouped items. So distance to 1 is 1. For example, take 15 as the input. Distance to 16 is 1, distance to 22 is 7. So naturally minimum is 1, so it is grouped into cluster 1. Next, 116, which is 0, 6, 19, 9 and 3. So it follows. Now we got a new set of values. Calculate the mean of that values, the centroid of 15, 15 and 16. And here 19 all the way to 65. Recalculate the distance. We get a different set of group. Again recalculate the average of 15 all the way to 22 and 28 all the way to 65. Only these values, okay? And then continue. 19.5 and 47.989. I recalculated in fourth step. No change. It is still 19.5 and 47.89. That means the clustering is done. So the groups identified are ages between 15 and 28 and 35 to 65. Now what is a small point on hard versus soft clustering? In hard clustering, each data point either belongs to cluster completely or not. For example, in the above example, the customer is put into one group out of the 10 groups. Soft clustering, instead of putting each data point into a separate cluster, a probability or likelihood that of that data point to be those in those clusters are assigned. So you see here hard clustering segregates them completely. Soft clustering may have a probability, so there are chances that the clusters are overlapping. With that, let me thank you. See you in the next video. Bye.